Okay, so more chain rule. So what do you guys think here?
Rewrite it.
Rewrite it?
Yeah.
Okay. How would you rewrite it?
X.
X,
U,
parentheses, 1 minus x squared to the 1/2.
yes.
Actually, could you do our
Would we
product
be
rule?
doing the product rule then,
So
mixed with it?
I believe, looks like we're going to have a product rule, and within that product rule, you're going to be doing the chain rule.
Okay.
You have to do the product rule because you're going to be taking the derivative of the product of x times that quantity to the 1/2. So there's two things that are being multiplied together. We're taking the derivative of those, therefore you have to use product. Then when it comes time for you to do the derivative of this part of the product, you'll have to use the chain rule to do that derivative. Okay?
Yep.
So this kind of becomes fairly common as our derivatives get a little bit tougher. So make sure you can kind of follow along and ask questions as we go here. I really try to organize my stuff with parentheses because the problems start getting more advanced and I need some sort of organization to know what I've done so far. So that's what you're going to see me try to do. So product rule. What is product rule?
1d2 plus 2d1.
1d2 plus 2d1. So 1, very simply, is just x. Then d2 is going to require me to do the derivative of 1 minus x squared to the 1/2 power. Okay? To do the derivative of 1 minus x squared to the 1/2 power, what are we going to do? So chain rule. So Amanda, can you tell me what we would get? Not quite sure? Okay, Libby?
Not quite.
No?
1/2.
1/2 gets moved to the front.
Parentheses 1 minus x squared.
Parentheses
negative
1 minus
1/2.
x squared to the negative 1/2
Minus the derivative of the middle.
times
Negative 2x,
the derivative of what's inside.
which is negative 2x.
Should be negative 2x. Okay? When you do the chain rule, again, you kind of pretend like this is u to the 1/2 power, and the derivative of u to the 1/2 power will be 1/2 u to the negative 1/2. Because we're using u substitution, we then have to take that times what the derivative of u would be. And we're kind of calling this 1 minus x squared, that's our u. So u is 1 minus x squared, so du would be negative 2x, correct? The derivative of u, the derivative of 1 minus x squared would be negative 2x, okay? So, my answer here is going to be, so there's my 1, times d2 is going to be 1/2, I'll even put brackets around this, 1/2, 1 minus x squared to the negative 1/2, times negative 2x. So there's my 1d2 part.
And then,
Plus, this one will be simple, 2d1, well 2 you just leave the same. So 1 minus x squared to the 1/2. d1, what's the derivative of x?
1.
1. So I mean, I'm going to write it so you can see I've done it. You don't need to. I'm not going to make you write times 1, but I want you to see that I've done the 2d1 part there.
Is that our answer?
Okay? I want to clean it up a little bit. That's just a little bit ugly there. Okay? And nothing drastic. Yeah, I know.
I mean, you can get rid of the Wally list.
So, this negative 1/2 power, let's just go ahead and move that to the bottom side of the fraction, okay? This is all being multiplied together, right? So sometimes it might help you, because I know sometimes that's a struggle. It might help you to kind of almost, when something is not a fraction, to think of it as being over 1, so you can tell maybe what's going to be on top and what's going to be on bottom. I can put this over a 1 as well, okay? So you can kind of see that. This is a negative exponent, so I'm going to go ahead and move that to the bottom side of the fraction, where then your exponent just becomes positive, right? Okay? So I'll have 1 minus x squared to the positive 1/2 down here. So I've taken care of this part of it, simplifying, right? Well, what's left? X times 1/2 times negative 2x. Okay? X times 1/2 times negative 2x Well, the half times the negative 2 would give me negative 1. So that's taking care of this part and the negative 2. You still got the x times x. So x squared. So really you just have a negative x squared on the top. If I take x times 1/2 times negative 2x,
Oh.
you get negative 2x squared over 2, right? For those of you giving me some funny looks.
So you just
Gotcha.
skipped a step for the top, basically.
Yeah, the 2's cancel each other out, and that gives me a negative 1x squared or negative x squared. Plus 1 minus x squared to the half. And now I call it good. You've gotten rid of negative exponents.
Would you, I mean, do we even have to leave the 1 on the top? Because since it's,
No.
yeah,
Nope.
that's just. And then do you mind if we change the halves to square roots instead?
If you change those to radicals, square roots, I don't have a problem with that. That would be fine.
Okay.
The book potentially could go a step further, making, because this one actually would come out, I'm thinking, kind of nice. They would make a common denominator and then add those two fractions together. It actually is not that difficult. I'll show you. This would be fine by me, okay? Just FYI, alright? But to make them have a common denominator, I just need to multiply this fraction by this, right?
Which would take
So
those-
1 minus x squared to the half on the bottom, 1 minus x squared to the half on the top. Well, you take this to the half times this to the half, you get that to the whole, or that to the first, because you add exponents. So really, you just have 1 minus x squared there. So you'll have your negative x squared plus your 1 minus x squared, because that's what this times this just equals 1 minus x squared, all over your common denominator of 1 minus x squared.
and then
the
simplify
half.
it.
Then they'll simplify negative 2x squared plus 1 over in, you probably would see this, 1 minus x squared in the radical.
That looks a lot neater than 2 steps above.
Yeah, and that's probably why the calculus book is gonna go that far, okay?
But there's more room for error.
Yeah, there's more room for error, and you
But
gotta
more room
understand,
for
depending on
practice.
what your calculus teacher in college might ask for, are they just wanting you to simplify the derivative as far as you can, or are we actually gonna use the derivative to find something else? Are we gonna use the derivative to find an instantaneous slope, to find an instantaneous velocity? If that's the case, okay, if you're using the derivative to find something else, alright, you maybe could have left it like this, although that's still kind of nasty to work with. This would have been a huge step up to work with this if you have to plug values in for x and things like that, if you're finding slopes or you're finding velocity, stuff like that, or minimums or maximums, okay? So, yes, this is definitely then the simplest to use, but there's so many steps to get there, it might have been just as efficient to plug it in already up there. Okay? Are you guys understanding what I mean when I'm talking about that?
Yeah.
Okay. Alright, so there's an example, number 25. Again, it wouldn't shock, or I would be fine you leaving it like this. You've gotten rid of all your negative exponents, that's good. Go further if you want to, okay? Just understand there's potential for error. If we're just doing derivatives and I don't care how far you simplify, this would definitely be fine. Okay? Alright. Let's look at number, your assignment, by the way, on the new ones are 25 through 32, 45 to 47, 57 and 79.
Do you mind writing that on the board?
Did somebody get that?
25 to
Yeah.
32.
20?
25 to 32, 45 to 47, 57 and 79.
I'm at
Help them out, I'm helping Erica
So
here.
25 to 32, 40,
5 to 47.
And 37 scores, so you
And
just do
then-
slashes.
57
Not-
They already have
and
two
79.
scores in that.
79.
You need a slash and then they're new. Yep.
Do you mind if I raise it? Okay, thank you.
So help me out now, I have my computer.
25 to 32, 45 to 47, 57, 79.
Thank you. Okay, so more chain rule stuff, I just did 25 there with you. Take a glance at those other ones in your textbook. Pick one, looks hard.
22.
22 is not even assigned.
22 is yesterday.
Oh, yeah.
32.
32.
Yeah, sure, that looks fun.
22 is going to be similar to the one I was working on in class right at the end yesterday.
Yeah.
So we got a pretty good start on that one.
So
Yeah, yeah.
32 would be using
yeah,
the
this is
quotient
32.
rule
So-
instead and doing essentially the same thing.
32, let's do it.
No, except the other way.
Alright, so 32, g of x equals the quantity 3x squared minus 2 over 2x plus 3, all of that raised to the third power.
I'm gonna save that.
Tori says, would you just distribute the power? And I'm assuming she means rewrite it as the quantity 3x squared minus 2 to the third power on top, and 2x plus 3, that quantity to the third power on the bottom. Okay? Certainly could. Then you're going to, I'm trying to think what would be easier. Then you're going to do the quotient rule and have two chain rules within that quotient, which would be fine. I mean, I think we'd get the same place. In fact, I'd be interested to see how far off after the first step we would be and what sort of simplifications it would take to make it look the same. But I probably would just do the chain rule right from the get-go, because then you'll have to do, you'll just have to do the quotient within the chain instead of two chains within a quotient. Okay? Again, neither one would be wrong. One usually ends up being a little quicker and easier than the other, and with practice you start to figure out which of those ways end up being better for you. Okay? So, g prime of x would equal. Okay? Bryce, can you help me start? Oh,
Yes, you can.
Alright.
just help me start.
3.
3 is a good guess for starting.
Yeah, 3.
So we write our 3, then what?
Parentheses.
Parentheses.
The whole thing.
Do you want to do it, John?
No, I know. 2.
What's in the parentheses?
3x
The same
squared
thing.
minus 2.
Same thing, right?
Low.
Over 2x plus 3, and then that's raised to the
Second.
second. But you're not done, because you still have to then what?
Derivative.
Multiply it by the
Derivative.
derivative of what's inside.
So that's where the quotient will come.
So times, now let's do the derivative of what's inside.
So 1
Square of what's
Low,
below.
d high. What's d high?
6x.
6x.
6x
That's it, right? Just
Yep.
6x.
minus
Minus I.
3x squared.
D low.
2.
2, very good.
Um,
Over
What's
square of what's below.
12x squared plus. What's 3 times 6?
Okay?
yeah, that's not too bad.
So, again, I think it's important to try and write it out, use some different brackets or grouping symbols, if you will, so you can kind of see what you're doing. Here I did the derivative of the thing as a whole, but then I multiplied it by the derivative of what's inside. I can see my quotient, and now I kind of go from there just a little bit. Okay? Yeah, I want to see if we can simplify that a little bit. Let's just simplify maybe that in there first to see if the numerator gets a little bit nicer. I'm not sure if it does, but we'll see. So here you'd have 12x squared plus 18x. And here you'd have 6x squared minus 4.
Can we write out that step?
Okay,
And then wouldn't you subtract out 6x
so I'm
squared?
distributing.
Yeah.
So that it then becomes 6x squared plus 18.
Do you want me to write it and then write it again?
No, that's fine.
So if I combine my like terms,
6x squared plus 18
Oh.
minus, or plus
plus
4.
4, yeah.
Plus 4. Plus.
6x squared plus 18x plus 4 over 2x plus 3 squared.
Let's FOIL it out, let's do it. Let's do it.
You know, it actually might have it on the top, because if it's a 2x and a 3x, and that's, would have to be
Can
1
you
and 4,
distribute the two?
and then 4 times 3 is, no, that doesn't get out, what about 2's, 2 times 3 is, nope, that doesn't reach it, never mind. I don't
Here's
think-
probably how I would write my answer to see if you follow my work here. I would probably write 18x squared plus 54x plus 12 times 3x squared minus 2 squared all over 2x plus 3 to the 4th.
Multiply the 3 by the top.
Made everything become a fraction. I took the 3 times this over here, so I distribute it to get this, right?
Yep.
I took 3 times this.
Why wouldn't you have
How
to
did
take
it get
three
to the
times
fourth, though?
3x
Oh, that's
squared
squared,
minus 2
never
on
mind.
top of that.
Brother.
If I take 3 times 4 times 5, do I need to take the 3 times the 5 and the 3 times the 4?
No.
To get that answer, can I just take 3 times 5 and get that answer? So it should be 15, take that times 4.
Yep.
So you don't need to distribute the 3 to both things.
Because there's no plus, it's all
Okay, in fact, I can't distribute the 3 to this one yet, because this one still has to be squared before I can multiply in order of operations. Where this one, there is no more that quantity raised to a power, so that's why I chose to take 3 times that quantity.
Would you want us to bring it down all the way there, or the one above it fine?
I'm probably gonna be okay with this right here, to be honest.
Just
Alright.
to double check with powers, would writing it for just the 3x squared minus 2 over 2x plus 3, all of that squared, would that be equal to, in parentheses, 3x squared minus 2 squared over, and then in parentheses 2x plus 3 parentheses squared?
Yes, when you have a over b squared, that's the same as a squared over
Okay.
b squared.
I just wanted to double check for the
Yep.
bottom parts, because...
And that's how I'm getting this to the 4th.
Fourth
Right.
was times. You just
Because this is 2x plus 3, that quantity, the second power on the denominator. Well, here's another 2x plus 3 to the second power on the
And
bottom.
then it just adds
Add
together.
exponents.
And that's why
So that are
first I was
we-
like, huh.
I'd,
I was like,
I'd
huh.
stop there. Very, very seldom are you going to want to FOIL things out, leave them as factors. Now, distributing, I think it makes sense to do, because when you just have to distribute, you can potentially clean things up a little bit. I mean, we at least didn't have a product of 2 things minus another product. We were able to get it to just a fairly nice expression. Okay,
Yeah.
it's not wonderful, but it's not awful either. So anyway, I'd probably stop there. Yeah, I suppose this is factorable. I mean, you could take a 6 out of it. If you take a 6 out of it, you'd have 3x squared plus 9x plus 2.
But why bother?
Because sometimes having things factored completely is beneficial, because you could see where it could cancel with something in the denominator. You know, because like let's say we had a 12 down here or something.
Yeah, but, okay, yeah.
Then by pulling that 6 out, you could reduce it.
Yeah, I get that, but.
I'm just saying
With
that,
this-
that happens, I mean,
Yeah.
that's, and so I want, if you take this again next year, or,
Yeah.
you know, you're taking an AP exam, and the choices have things simplified completely, I wanna make sure you've been exposed to doing that.
To doing that, okay.
Plus, practice never hurts unless you're doing it wrong.
Valid point.
Yeah, that's a good point.
Practicing hurting yourself.
Okay,
Why did I give
alright,
him that
let's not even
idea?
go there. Okay, so, that was a good one, you got to see some more chain rule and rules within that chain rule, so.
Okay.
Okay, we're down to about 3 minutes, is there any other
To
one?
turn off the thing.
No, is there anyone other like to start?
The test?
Actually, I'd like to do, I'd like, you gotta do 45 and 47, there's 2 of them with trig, let me start 46 real quick. 46
Yeah.
is y equals sine of pi x. Okay,
Yep, we should definitely do
in this case, I do think it's good to think of it,
There it is.
let's let u equal pi x. So really I have y equals the sine of u.
Mhm.
What's the derivative of sine u?
Cosine u.
Cosine u, but then you need to take that times du, right? Because you're doing the chain rule.
Pi.
So y prime would equal the cosine of pi x times, if u is pi times x, what's the derivative of u?
Pi.
Pi. Because remember, pi is a number. Like, if this was a 5, what's the derivative of 5x?
5.
5. So what's the derivative of pi times x? Just
3.1.
pi. Okay? So pi right back here, I would make it look nice and write it as pi cosine pi x. So that's a chain rule being done on a trig equation. Trig ones tend to trick people up once in a while, so I wanted to
Yes.
show you one
Yeah.
of those.
that. That's definitely a for sure step.
Okay, so that's 46, you can do 45 and 47, hopefully after seeing that. Please get your homework done on this, guys, very important, I know not a lot of you had it, complete.
You just don't either.
Oh, I did. My dog just ate it.
Okay, so here's all the homework right here. That was from yesterday, chain rule stuff, some easier ones. Today it got a little bit tougher because you're doing rules within the chain rule, or vice versa. Okay, so please get a lot of practice on that over the weekend.